We're going to wrap up learning how to solve equations by looking at literal equations. Now, that sounds a little funny, so the first thing you're probably going to ask is, okay, what is a literal equation? Well, a literal equation is an equation that is mostly variables. There will be some numbers mixed in there, but it's going to have 2, 3, 4, maybe more variables. I know what you're thinking. Okay, you've just made me deal with all these ugly looking things that have one variable in them, and now you're going to put more than one? Well, yeah, we are. But as you work with them more and more, you'll become more comfortable with them. An example of a literal equation are formulas. You've been dealing with formulas. You've done formulas for area, volume, other types of things that you have used a formula for. So if you look at the formula for a circle, a equals pi r squared, this is a literal equation. It has the variable a, which stands for area, and the variable r, which stands for the radius. We know pi is not a variable, it's a constant. It has a numerical value. So this is an example of a literal equation. So how do you solve a literal equation? Well, you solve a literal equation just like equations. We're going to use inverse operations to isolate the desired variable. So what I'm going to do is I'm going to show you a type of normal equation that you know how to solve, and right beside it I'm going to show you a literal equation that is solved very similarly. So look at the two, compare them, see how they look alike. Like I said, this is going to look really weird because the answers are going to look weird. The whole process is going to look a little strange, but as you do it more and more, you'll get better with it. Okay, so here I have 3 equals x minus 2. I know I'm trying to isolate x. I've got minus 2 out beside it, so I'm going to add 2 to both sides, and I get x equals 5. Where did the 5 come from? 3 plus 2, right? So let's look at a similar looking equation, m equals c minus s. See how it looks similar to this one over here? We're going to solve for c. Well, it's c minus s, just like this was x minus 2. So what I've got to do here, I'm trying to isolate c. I'm going to have to use my inverse operation to get rid of minus s. Well, the inverse operation to subtraction is addition. So I'm going to add s to the right, and whatever I do to one side, I have to do to the other. Okay, so this is just like the plus 2 plus 2. So this minus s plus s becomes 0, just like we would expect, and we're left with a c on the right-hand side of the equal sign. Well, now over here I had 3 plus 2. Those were like terms. I could add those together. 3 plus 2 is 5. But m and s are not like terms. I can't just add them together. So what do? Well, I copy them. M plus s. So my answer here is c equals m plus s. Looks a little weird, but it would be very similar over here if we said x equals 3 plus 2 instead of 5. They were just like terms. Okay, let's look at a very straightforward multiplication equation. 12 equals 3 times y. So this is 3 times y, so my inverse operation is division. I'm going to divide both sides by 3, and I get y equals 4. Okay, no problem. Well, here is one that's a literal equation, d equals rt. This is a formula for distance, and they tell me to solve for t. So I'm going to isolate t. Well, what's keeping it from being isolated is the r, just like the 3 was with the y over here. This was 3 times y. This is r times t. Well, my inverse operation to multiplication is division. So I'm going to divide both sides by r. I'm dividing both sides by r just like I divided both sides by 3 over here. The r over r, that simplifies to 1, right? Anything over itself is 1, and I'm left with t on the right-hand side. And on the left-hand side, I have d divided by r. I can't do anything with that. There's not even any numbers there. So I write my answer as t equals d over r. That's all I can do. I'm done. It would be very similar over here if I had written y equals 12 over 3. But I can simplify 12 over 3, so I did. Now, here's a formula you're familiar with, the volume formula. Volume equals length times width times height. They tell me to solve for h. Well, h is here, and I have L times W times H. And I'm going to show you a little trick that you can sometimes do when you've got a big string of things multiplied together. Since they're all multiplied, together, I can divide by at the same time. Since I need to get rid of the L and the W, I'm going to divide both sides by L times W. The L's will cancel, the W's will cancel. I'm left with H. And on the other side, I have V over L times W. Can't do anything with it, so what do? I just write it. Okay? Here's a division equation. M divided by 3 equals 7. The inverse operation to division is multiplication. I multiply both sides by 3. These 3's cancel, and I'm left with M equals 21. Here's one that looks a little similar. This is one you'll actually use in science if you haven't already. D equals M over V. This is density, mass, and volume, I think. And so we're solving for M, and it says that D equals M divided by V. So I need to do the inverse operation of division here. So I'm going to multiply both sides by V. These V's are going to cancel. I'll be left with M, and I've got V times D, so I can write that as D times V or dV. Okay, so there's all your little one-step looking equations. Kind of weird, huh? Well, let's look when they give us some fractions. Okay, here's a normal equation, I call it normal, that has a fraction involved. This is 1/4 times z. We've talked about that fractional coefficient. I multiply both sides by the reciprocal, right, which is 4 over 1. These 4's will cancel, and I'm left with z equals 28. Well, here's a familiar formula. Area equals 1/2 base times height, area of a triangle, right? Well, I need to get rid of this 1/2 first. So to get rid of the 1/2, I'm going to multiply both sides by the reciprocal. So I'm going to multiply the right by 2 and the left by 2. This 2 and this 2 will simplify. They become 1. I'm left with BH equals 2 times A. But I'm not done. They told me to solve for H. So I've got B times H. So that means I need to divide both sides by B. So these B's will cancel, and I'm left with H equals 2A over B. There's not anything I can do with this, so I just copy. Okay? Now, here's one of the fractional ones we looked at that we do a little different or a little backwards to the way we normally handle this. Remember, this fraction bar, this division bar, is a grouping symbol. So this x plus 3 is in parentheses. So the first thing I have to do, it's divided by 5. So I'm going to multiply both sides by 5. These 5's will cancel, and I'll be left with x plus 3 equals 20. Then I'll have to subtract 3 from both sides and get x equals 17. Okay, this one, a equals b plus c over d. They tell me to solve for b. Well, here's b, and it's in that fraction, right? So it's grouped. So I have to get rid of the d first. Is divided by d, so I'm going to multiply both sides by d. These d's will cancel, and I'll have dA equals, and over here I'm left with b plus c. I'm solving for b. Always look to what you're solving for. It's plus c, so I will have to subtract c from both sides. Plus c minus c is 0. I'm left with b, and here I have dA, and I'm subtracting c. So what does that look like? dA minus c. Okay? All right. Let's look at two-step problems. Here's your typical two-step equation. 2x minus 5 equals 13. First thing I have to do is take care of this minus 5. So I'm going to add 5 to both sides. I get 2x equals 18. Then I have to divide both sides by 2. Then I get x is 9. Okay? Now look at this one. Do you see how it looks the same? ax, 2x, minus 5, minus b. I'm solving for x, so I need to take care of this minus b first. I'm going to add b to both sides, and I get what? ax equals c plus b. I have to write these separate because they're not like terms. I'm solving for x. This is a times x, so my inverse operation is division. I'm going to divide both sides by a, and I end up with, these a's cancel, x equals c plus b all over a. You good? All right, let's do a couple of more that are these two-step type. So this is ax plus by equals c. This is an equation that we're going to get to know rather well later in the year. And we're going to be manipulating this. We're going to move this equation all over the place. At this particular time, we're going to solve for y. So we look at this term with y. We're going to save it. We need to wait to deal with it. We've got to get rid of ax first. So since it's ax plus by, we're going to subtract ax from both sides. So I end up with by on the left and c minus ax. There's not anything I can do. I just copy it. I'm solving for y, so I come back here and I say, well, it's b times y. So I'm going to divide both sides by b. These b's will cancel, and I'll be left with y equals, and I really just copy this, c minus ax over b. Now, to make you feel a little better, maybe when we start working with this later, this a, b, and c will be numbers. So there will be more numbers than variables when we start working with it. Okay? All right, one more. A equals p plus PRT. This is an interest type problem, I think, formula. They're telling us to solve for t. So we find the term that has t in it, and we're going to just wait. We need to get rid of this p first. So we're going to subtract p from both sides. We get a minus p on the left. This p minus p becomes 0, and we're left with PRT. Okay, a minus p equals PRT. I'm solving for t, so I look right here. Well, this is p times r times t. So my inverse operation is division. So I'm going to divide both sides by p times r. Remember, when it's a string of things multiplied together, you can divide them all at one time. Divide both sides by pr. These p's, these r's will cancel to give us the t that we want. We want t to be isolated. This over here, we're just going to have to copy. So t equals a minus p over p times r. All right, I know it looks weird. Make sure you've got it all copied down. Maybe go back and try some of these by yourself to see if you can do it, and we're going to do lots of practice in class.